Good morning and welcome to this episode of Mastering the Machine for April 10th, 2022. This morning I talked more about my new book, Maintenance and Troubleshooting in Industrial Automation, and covered a couple of sections that are available for download in the Automation Academy. Hope you enjoy it. I also showed a little bit of the Automation Academy itself and talked a little more about mastering the machine and some of the things that I'm working on, trying to find people to help me build some control panels in the South Florida area. So check it out. If you know anybody in that area that is a control panel builder or designer, hit me up. Thanks. Good morning and welcome to the latest webinar in the Mastering the Machine series from the Automation Academy. My name is Frank Lamb, and it is the 10th of April, 2022. Nobody has logged on yet that I can see, but today's topic is kind of a continuation of last week's topic on maintenance and troubleshooting. I did just publish a book. There's the picture of the book on the screen. Hopefully you can see it. It is branded with the Automation NTH University logo. They kind of helped me put this together and sponsor it. So I'm going to get some of the basic things here out of the way, talk a little bit more about the original Mastering the Machine document and the Automation Academy and kind of why I do this. What is Mastering the Machine? In 2013, I created a document called Mastering the Machine, and I'm going to show you a little bit of it because there's something that kind of pertains to something I'm needing to work on in the next couple of weeks that applies to the document itself. But anyway, I named this webinar after that document, Mastering the Machine. And it was kind of a document telling how to plan machinery, build it, and document it after I had left Wright Industries, which is a big machine builder here in Tennessee in the United States. So it has evolved into a training and automation website called the Automation Academy. And I do these webinars every few weeks. It used to be every 2 weeks. I say bi-weekly here, but it's kind of turned into something that's been every 3 weeks lately, mostly due to my schedule. That's been a bit of a problem, just trying to arrange things where I can free up some time to do this. So this morning, I did want to go over a little bit of what the original Mastering the Machine document was. So just like that picture there, this is the document itself. And one of the particular things, there's a little table of contents for it. One of the particular things that I talked about was you can, it's kind of blurry there. Let's see, there we go. You can build your own equipment if you are running a plant, but it takes a little management from your end, right? If you are building equipment in-house, the lowest cost method of doing that, right, as far as hardware and labor, is to use your own internal labor because there's no markup. There's no project management. Basically, you are doing the project management. And that's the way that kind of works. You can do it entirely in-house. You can use multiple vendors and manage all the relationships between the vendors yourself. That would be a medium cost, and a medium resource requirement. And then if you do things turnkey, of course, you can find companies that will do most of the work for you, and you're paying them for overhead, right? You're paying them for documentation, you're paying them for project management. You're telling people, just come into my plant and take care of everything. So the reason I'm kind of mentioning this, I have a application. Of course, I've mentioned American Beverage Depot before, where the owner of the company is doing some pretty quick plant expansion, and he needs some help. And he has asked me, for instance, to, kind of dig my wife out of retirement, who she used to build control panels. She's very good at wiring things and, mounting all the stuff. And it would be a lower cost method to do that because she would just have to, the owner of the plant would just have to pay the labor to do that. And he knows from her previous results that she does a really good job, and I can help with that. And he could use maybe some internal resources but he really doesn't have a lot of the internal resources. And my wife really is not interested in going back in and starting to wire panels again. She's basically retirement age and kind of doesn't want to do a lot of physical work anymore. So she's kind of said, you know, I really don't have time. So all of a sudden, I'm in a position where I need to use what's in this Mastering the Machine document to get things done for him. What I've told him is, you know, you're going to save a lot of money, for instance, by building a control panel, especially a 2-door control panel like he needs down in Miami, Florida, rather than having somebody build it up here like at my facility and then ship it down there, because he would have to ship a lot of the components. Somebody would have to source all those components, right? Go to all the vendors and get everything. He has some of the components himself. He likes to use some used stuff that he has in trailers at his facility. But to do that, people would have to pack all that up down there, ship it here. Then we'd have to inventory it, figure out what's available, and figure out what we have to buy. Somebody has to draw it. That probably would default to me, but that I'm not a cheap resource for electrical drawings, right? I'm kind of more in the later part of my life and require a little more income than your typical person who's just doing drafting. So I don't know that I'm a good resource for that. So we need to find another resource to do electrical drawings, to build the control panel, to inventory all the stuff and find out what he's got down there. And so one of the things I told him is that it would be better if you can find somebody in your immediate area. Well, same thing. He doesn't have the time to do that. And he doesn't know that if he did find somebody that they're any good at what they do, right? He'd have to find somebody with experience. He is possibly coming up here to visit next week and visit Automation NTH. They represent a possible resource. They have a giant panel shop. They do very good work, UL work. He could go in there and see what they do, but all of a sudden, you know, now he's pinned to their schedule and they are very, very busy right now. It might be a month or 2 months, or they might not even be able to do it at all. They're also pretty expensive. So they build lots of panels for other people, large quantities, and he just wants 1 2-door cabinet to control some conveyors. So I don't know that that's a good resource for him either. I'm connected to a lot of people on LinkedIn that could possibly provide that resource. But once again, are they busy? Are they available? Do they do good work? So one of the things that I'm going to attempt to do in the next month or so is find somebody in the southern half of Florida that builds control panels. I'm going down there anyway to work on other parts of this project and other projects for him. So I could be checking on the panel where he really doesn't have the time and he doesn't have the people down there to go do that. So I'm going to try to figure out how to do some of the things that I've been proposing now for almost 9 years. This document's been out on how you can do things in-house or just use a few multiple vendors to get things done less expensively. I'm going to document a lot of that and apply it to you know, one of the things that I've been proposing in here. For those of you who are interested in this document, it is available for download on either one of these 2 sites. It's free, so you can just go up to it, and I do get your email address, but I really don't send out many emails, so you're not risking anything from that. In any case, that's a little bit about Mastering the Machine and its applications, what it's about. I'm going to be applying some of the things that I propose in there, and so be it. What is the Automation Academy? I'm going to show you a little piece of that here in a second too, because it applies to today's topic also. I created a membership website about 1.5 years ago now, and I have a lot of training videos on there. I have a library of a lot of documents, and I have just added a whole bunch more documents. It has a community with interest groups. The community is kind of under reconstruction. There are some forums on there, but there's not a lot of kind of like social media kind of stuff anymore on there. I was paying a lot for that and nobody was using it. So I'm kind of backing off on that and working on a little bit. And of course, we do have regular events like these webinars. So a lot of videos, a lot of webinars, things like that. A little bit about today's topic. I mentioned in the last webinar, which was about 3 weeks ago, that my new book is out, Maintenance and Troubleshooting in Industrial Automation. It's available on Amazon. I'll go ahead and slide this over here and show you what the thing looks like. Right, there is the book. It is a paperback book. It's really big. The list price on it is like $75, but you can see here people are advertising this for $57.75. There are about 9 different companies or people selling it, including Amazon directly. And of course, if you did a search for this, you would also find it at a whole bunch of bookstores. So you can get this book now online. I think I have the link on the next page. Yeah, there it is. So if you see this and you type it in, you could find this pretty easily online. However, the other thing I wanted to mention here is that on my website, right, the Automation Academy, that book was listing for $57, but you can join the Automation Academy for even as low as $9.99 a month, which gets you total access to the library. And if I go to the library here, you will see that there are a whole bunch of downloads on PLCs, things like that. And way down at the bottom, maintenance and troubleshooting. And I have taken the book and broken it into about 24 different sections. And I've even like extracted part of the tools and techniques multimeter section, and I broke it out and elaborated a little bit on it, on a little more on how to use a multimeter. Another document that's going to be coming up, I have a very good section on machine vision, but it wasn't particular to a specific branch or brand rather. So I'm going to put a Cognex document on there that talks about all the different products that Cognex makes and all their software and everything. I've kind of just gone to their website, pulled a lot of those models off, and made something like my Allen Bradley section that's in my PLC book. I think I have an Allen Bradley section and a Siemens section that talks about their hardware. That's an important part, obviously, of specifying vision systems. So that's a little bit about that. What my thought is on this Mastering the Machine webinar is that I was going to, in the next few episodes, take these sections and break them out and talk a little bit about each one of them. So today, I'm going to be talking about these 2 documents, these 2 sections of the book, basic troubleshooting and maintenance and mechanical. The basic troubleshooting section is actually in 2 different sections of the book. And it has the beginning part is just kind of machine observation. And let's bring this back down again. Machine observation. So the basic troubleshooting section, this is in the very beginning of the book. You can see this is kind of how I broke these out. I kind of put a little revision number in here, and I say extraction from maintenance and troubleshooting in industrial automation, which is, again, if you can see my little image here, it's a big book, right? It's got a lot of different sections, 384 pages long, lots of stuff. The first section starts right here, right, with this basics of troubleshooting. Describe techniques using in troubleshooting industrial machinery, knowledge required to understand machine operation. So a lot of the book is that prerequisite knowledge that maintenance people would need in order to troubleshoot machinery, you know, electrical knowledge, mechanical knowledge, all that. So I cover a lot of that in the book, but I also cover some basic maintenance and troubleshooting concepts here. So this section here, I mentioned understanding PLCs and computers, sensors, actuators, software, data types for numerical and text information, knowing about your product, knowing about your machinery. And I talk a little bit about the classifications of machinery that you may need to know about depending on your industry. Now, this doesn't apply to every industry, right? If you're in the chemical industry, I didn't cover a tremendous amount about, you know, chemical processes. I did cover a little bit of oil and gas, petroleum, and I covered beverage manufacturing because I'm involved in that. So I knew a decent amount about it. And I cover a lot about things like packaging machines, material handling, a little bit about the pharmaceutical industry. But this is not meant to be a book that is everything about everything, but it does have a little piece of a lot of different things, a lot of different sections. So let's go back in here. This is in the very beginning of the book. Let me see what page it's actually on. Probably page, the beginning of the book is basically page 13 after a lot of the introductory stuff and explaining what NTH University is, things like that. And the maintenance section starts on page 13. And I talk a little bit about machine observation, using your senses, watching machinery. I actually have some videos, and I thought about putting those on here today. Packaging machinery and box making machinery in beverage making and everything, but it doesn't really apply to the book, and it's kind of hard to present videos while streaming this. So I'm just going to go ahead and cover a little bit of this. Do machine operators have to load or unload parts or material? Does their speed affect the operation of the machine? So those are obviously important features. What is done to a product as it is processed? How fast does the machine or system run in parts or volume? So you can see a lot of that. If you watch machinery, you can time things, get out a stopwatch, see how long it takes for objects to make their way through the machine, see how long it takes individual stations to operate. And of course, you can monitor a lot of those processes with software. You can connect up with your PLC and program. How long did this operation take? Where is the bottleneck in my machinery? Does the machinery stop operating because of machine faults? Well, most machines do, right? If they detect something that's wrong, the machine is going to stop. If so, what must be done to get the machinery operating again? Is there an HMI or a display to help you diagnose problems? This book covers a lot of those details, right? So I mentioned here, consider taking notes as you observe machinery in operation. It's best to learn about it before you have a problem, right? You want to learn how the machine operates by watching it. I realize you get into a plant and you don't have a lot of spare time. People want you to fix stuff that's broken, but you do need to learn how the existing machinery operates. Take notes on it. People that can help you with that would be, for instance, the machine operators. Machine operators probably know more about that physical operation of the machinery than anybody else in the plant. So you don't go to the plant manager to ask him questions about that, or your maintenance manager. A lot of times you have to talk to the operator. At the same time, the operator is about the least likely person to know the technical side of how things work. So you have to understand well enough, understanding software, to be able to get into the operating part of the machine and see what the machine is intended to do and how the software drives it. That takes a long time to learn, right? And of course, a lot of what I've covered in the past has been PLC programming. That's a lot of where that comes from. Other things that you can do here, right, is you can use your senses. It's not only looking at a machine, you can also use your other senses. So visual signs of problems, easiest to find. You can look for leaking fluids or metal shavings, black sooty powder. That's signs that your machine might need attention. Burnt and blackened components on circuit boards, warped or melted plastic, and wear points. This is all just written stuff in the book. You can also, of course, use video recorders to analyze that. One of the things that they do at Automation NTH, which is, again, one of the sponsors of this book, NTH University, is they have cameras inside of their machinery that films every operating part of the machine. There are a whole bunch of just webcams, and it logs all the moving parts and everything into a bunch of videos on a computer. Not every machine has that, obviously. It costs a little bit of money and time. You have to have storage for all the videos and that sort of thing, but you can network that on a separate network than your control network. And if there's a problem with the machine, you can go dig through the video and find out what went wrong with it. Nowadays, right, web cameras are pretty inexpensive. Now, I will say Automation NTH uses some pretty nice high-end web cameras. They don't use the cheap ones. But that's a really good option. And that's one of the things that I may be helping implement at American Beverage Depot, right, which is going through, as I mentioned, this major change in the way they operate. They're getting certified, SQF certified and things like that. So they may have to do some of that. They may need some documentation of how their machinery is running. Video recorded, thermal imaging. That's one of the things people sometimes also overlook. You can use thermal imaging to identify hot spots in a cabinet. I have a little bit about that in the book, just kind of some pictures of thermal imagers and some of the manufacturers of them. And I do talk about that toward the end of the book. So those are all kind of visual things. You can also, of course, listen to machinery. Sounds change as problems appear. Grinding and high-pitched squealing sounds, that would be an obvious sign that something's wearing or misaligned. Banging sounds, whatever. So you need to know the normal sounds of your machinery and then be able to identify changes in the way that it sounds. One way to do that is you can actually take recordings of the way your machinery normally sounds and then compare it to current recordings, and you might hear some high frequency sounds in the recording and be able to actually compare them with each other. They used to do a lot of vibration analysis, which is sort of like sound, right? You would get sound waves that you could compare with previous vibration patterns, and you could do comparisons that way and identify whether something's wearing or changing. So listening to a machine is another way to do this. You can use touch. You must be careful when using touch, right? Some things are hot. So you can use the back of your hand, for instance, to check the temperature of a motor. And if it's getting really hot, you may need to go in and do something to lower the current in that motor or upsize the motor or service it or whatever. So sense of touch can help. Warmth, vibration. Again, you put your hand on a motor after, again, checking its temperature, and you can see how much it vibrates. You can check bearings and things like that way. Can be dangerous. If you suspect something is hot, approach it with your hand slowly. You can often sense the heat before you touch it. Use the back of your hand if you must touch something. So many components I mentioned here vibrate even when they're operating correctly. So knowing how much vibration is normal can be helpful. And again, there's electronic methods of monitoring vibration. You can pay people a whole lot of money to do vibration monitoring. We had Phil Scruggs on here a few months ago, and of course he talked about his very high frequency using, transforms and things like that, probably Fourier transform, fast Fourier transforms to analyze vibration. It's not always necessary to go that far. That's an expensive thing to do. So so vibration monitoring, again, can be pretty expensive. You can smell things in machinery, right? As rubber burns or wears, you can smell things going wrong with your machinery. So again, it's not always visual. Sometimes it's audio. There's electronic versions of audio. That's just like vibration analysis. You can record things and compare it to previous recordings. What else can you do to observe your machine? You can read the documentation about the machine, right? A lot of standard machinery has documentation associated with it. The time to read that documentation is before it breaks down. You don't wait until the machine breaks and then have to waste time reading documentation on how the machine operates. So in addition to watching machinery operate, you should read the documentation and see how it's supposed to operate. You can also identify things like, do we have a replacement part list? Does it list every part in the machine? And can I identify, for instance, alternative parts? Can I get, photo eyes to me are photo eyes. They, especially simple photo eyes. If they're just on and off, they're through beam photo eyes or retroreflective. It doesn't matter if you get them from Banner or Automation Direct or Keyence or whatever. As a matter of fact, some of those brands are a lot more expensive than others. And as I mentioned, American Beverage Depot tends to use a lot of used equipment. There's nothing wrong with that. You do need to identify, though, if you're using things like quick disconnect cables, can I take the existing quick disconnect cable and plug it into a different brand of sensor? Most of those quick disconnect cables are pretty standardized across the industry. So it doesn't matter, pin 1 is maybe positive, pin 3 is negative, and pin 4 is the signal. As long as that's true, it doesn't matter what brand of photo eye you use. So knowing your replacement parts list and identifying alternatives early is a pretty good thing to do. I've actually got some exploded parts views in the book about internal workings of elements of machinery. I don't have that up right now, but let me see if I can identify it in the book here. I know at the end I have a pretty extensive write-up on a particular machine at Automation NTH. And one of the things I pulled out of it was an exploded view. Yeah, here it is, of their drives. So it's hard to see here, but that's one of the pages in the book. And you can see here that the exploded view of the drive has a lot of pointers to different parts of it. And then you can, see how to take things apart and things like that. So that's very useful, right? Not only in repairing the thing, but telling what the individual components are. Electrical schematics, there's a big section in the book on reading electrical schematics if you don't know how to do that. For people that are in the process control industry, it's interesting. I go to Automation NTH and I talk to them about piping and instrumentation diagrams, and most of the people there have never even heard of them. Unless you're in process control, it's not something you use. But the people that are in process control think that's the golden holy grail, right? That's the thing that you actually use for everything. Well, that's not true in standard, what I would call digital machinery, digital manufacturing, bit banging, right? That's not something that people in the automotive industry, for instance, use P&IDs. You can look at the PLC program. Now that takes a good bit of training to understand what you're reading. That's why people take PLC classes. You can even look at the hardware configuration in the software. You don't have to understand the PLC program itself to look at the hardware configuration. But what that does is it tells you where all the IO cards are and what they're connected to. It's almost like schematic diagrams, right? I can see my IO list, see where my photo eyes and motors and all those things are ahead of time, once again, before the machinery breaks down. So that's a little bit of a look at the very first document, right? This basic troubleshooting. Do your research, right? You can look at books and catalogs. You can find a lot of this stuff online. So listing things, right? Websites and things like that would be a very important part of all this, listing them ahead of time. And I have a little exercise in here where I have people list documents that might be available to them. The troubleshooting section of the book itself is actually much later. So it's toward the end of the book. And so the beginning part, I think I said, was on page 13. The troubleshooting section, I'm gonna look here real quick. There's a whole lot on electrical schematics and things like that. And then I do classical troubleshooting. And I want to say that's on, it's not jumping straight to me here, but it's on like page, there we go, page 220, something like that. So I merged those two sections in here. What is meant by troubleshooting? 3 elements to solving problems: identify and document what the problem is. Writing down what the specific problem is important. Determine why the problem happened, and then determine a solution to the problem and prevent it from happening again. Here are some of the techniques that can be used in troubleshooting systems and equipment. Start with the simple, right? Start with the things that take the least amount of time, because you can get some things out of the way that way. You might find it very quickly just by looking for something like ask the user if the receptacle has power that is plugged into, or if the device is plugged in. Sometimes people get upset when you call a helpline and somebody asks you those obvious questions first. Hey, is your computer plugged in? Well, most people know enough to know that their computer is plugged in. Did you turn the power switch on, right? People get upset when you call Dell computers or Microsoft and they ask you those dumb questions first. But those are a lot of times the basic things that you can check very quickly before getting into checking all these complex things. So start with simple things. Begin from a known good state if you can. So starting a machine from a home position with no parts you can identify problems a lot of times. Sometimes your problem is not with the machine, it's with the parts, right? So you need to have good parts. You need to have the machine empty and then start introducing known good parts if possible. Again, that sometimes takes less time than digging into the less obvious things or getting your meter out or getting your laptop out. Those kind of things and connecting up can take a lot of time. So a well-known example of this is rebooting a computer. Clears the current RAM memory of the processor and restarts the operating system. You know, machinery a lot of times is the same way. Sometimes people power it down and they restart the PLC program. Now, I'm going to tell you from my experience, that usually means you have a problem in the PLC program. You should not need to do that. If you're having to shut off power to your system and reboot your PLC or whatever, somebody didn't program the PLC properly. I know this because I program PLCs. I've been doing that for about 30 years. It's a big part of what I do. And if you're having to home the machine by powering things down or e-stop it or whatever, you can definitely fix that. That is a programming issue, right? To reset faults and things like that. So begin from a known good state. Substitute components. People sometimes call this shotgunning, right? If I have, I can just start replacing photo eyes randomly, right? Just replace them all with good components. That's expensive, it's time consuming, but it is a possibility. It's probably the most expensive. That's what I said here. This should be a last resort. You could end up destroying multiple expensive components, right? I take a known good component, I plug it into a cable and it burns up the good component. That kind of defeats the purpose of shotgunning, right? So you need to make sure that your power is correct and all that first. Use checklists and flowcharts. Here's an example of a flowchart. A lamp doesn't work. Is the lamp plugged in? They ask you that. No, well, plug it in, right? Is the bulb burned out? Yes, replace the bulb. No, repair the lamp itself, right? So this is a simple checklist, right? And there's something a little more complicated here called an Ishikawa diagram that's more or less the same kind of thing, right? This is an example of it. Here are all the factors that can contribute to a defect. Circle the ones that you find results for. So this is a famous kind of diagram. People call them fishbone diagrams or Ishikawa diagrams. Sometimes they even combine the two names and call it a Fishikawa diagram. And I put that down here, right? So that's a kind of a checklist that you can use or a diagram. Reproduce the symptoms. Sometimes that's a good way to fix equipment. See if you can make the same thing happen again. So kind of goes without saying how that works. And then there's something that we used to do in the military called the half split method. So I have a good signal here. I have no signal here. I check in the middle. I first check, hey, the signal's okay. I've just eliminated the first 4 steps of the analysis, right? So then I split it in half and I check the second part of the signal here. Hey, I don't have a signal here. I know that now my problem is somewhere in between here and here. And I check the third signal. I find a good signal. I find no signal. I've now isolated it to this specific fault. If I would have started at the beginning and just checked every stage, I would have had like 6 checks before I found out what the issue was. And here I managed to do it in 3 checks, right? Third check, I have identified the problem. I only did 3 checks there, maybe using something like an oscilloscope if this was an electronic system. Root cause analysis, people call this the 5 whys a lot of times. I kind of rewrote this and I said, you know, problem, a machine won't run. There's some famous examples in things like Wikipedia. I kind of rewrote this. Why? The machine won't run. Why? It has no power. Why? The circuit breaker tripped. Okay, so you reset the circuit breaker and it trips again, right? Yeah, the circuit breaker keeps tripping. Why? The circuit drew too much power when the motor got stuck. Well, now you're starting to narrow it down a little bit. That's the third why. Why? A part fell into the drive chain. Well, how can that happen, right? You're supposed to have a cover on the drive chain. Why? The chain cover was left off after servicing. This is a root cause. So sometimes you have less or more of these causes, right? You may only have 3 whys or you may have 7 whys, But this is part of the Japanese kind of Kaizen methodology of improving machinery. It comes from the Toyota production system. So I kind of put that in the technical troubleshooting section of the book. A lot of this came from, again, company Dexcom wants a lot more troubleshooting material, and NTH builds some really complex machinery. So we need to build a really good, robust troubleshooting course. And that's where some of these ideas came from, is just documenting it all into kind of a standardized piece of paper. And then, of course, I turned these into these separate documents. And that's what this webinar is kind of about. Intermittent and multiple symptoms. That's one of the hardest things to figure out what's wrong with a machine. Most difficult problems to solve are those that are intermittent in nature. Sometimes it works, sometimes it doesn't. You can use things like trending in PLCs. You can trend on your HMIs. You can have a computer that does that. You can also, as I mentioned before, have things like web cameras inside of the machine recording everything that happens. And you can see sometimes what those intermittent issues might be. Nowadays, monitoring things electronically is fairly inexpensive. Adding analog points, things like that. This was not true, say, 30 years ago. So things are getting so inexpensive now that it's pretty easy to add devices. If causes like heat or humidity are on the list, artificial stresses like heaters or humidifiers can be used. We run into this a lot down at American Beverage Depot. It gets very hot in the summertime, very humid, so water condenses on things. So temperature controlling things can be important for reducing some of these causes, right? Multiple symptoms and things like that. So that's a little bit of a look at one of the documents, right? I did break this into 24 different documents. Some are really long, some are really short. And then I put some exercises in here. I talked about correlation and causation. If you get the book, right, the answers are in the back of the book. I did have a complete list of all the answers. And if, let's see, if I go to the list of documents, there we go. This is a list of the PDFs that are available for download in the Automation Academy. And you'll see that one of the last documents, if I can find it here, is the answers. So that's another document you can download. Where is my scroll bar? You'll just have to expand it out here. We'll just drag it down. There we go. Appendices, right? Appendices out of the book, and exercise answers. So these are the documents that are available for download in the Automation Academy. Like I said, the book lists for $75. It's advertised right now on Amazon for $57. I don't sell the book. And one of the reasons is it's really hard to fulfill orders for the book. I don't want to ship them. So that's one of the reasons I don't do that. So as I mentioned previously, here's the book on Amazon. Other people sell it. So it didn't even show up until somebody picked it up off of the book list. And right, you can see now there's 9 different people selling it. I'm sure one of those companies is just Amazon themselves. They actually stock it. And you can also get it from, I Googled it, and it's available at all bookstores now. So all that stuff's available if you want the physical book itself. But again, $9.99 a month, you can download all the sections yourself, and you've got PDFs of it. Looks like we got somebody here in chat. Okay, that's cool. Samarjit, looks like you're here. That's good to see you. A couple other people there online. What I'm doing here is, again, I'm just showing kind of some of the sections in the book. This maintenance and mechanical, one of the things I wanted to cover today, right, was basic maintenance. This was stuff I know what maintenance is, but I really never looked at a lot of the classical forms of maintenance and the different types that they are. So these are some of the definitions, and I did put them into the book. I had heard of the acronym of, MRO. What is that, right? Maintenance, repair, and overhaul. That's actually what that starts for. So if you hear people talking about MRO, that's really what they're talking about. And all I did here in this beginning little section is broke those into the different types of maintenance. Preventive maintenance, which is a lot of what people do, going around working on sections of the machine to make sure they don't break down in the future. That is the least expensive maintenance. You're able to do it on your own schedule when the machine is down during non-production time. So that is one of the better ways to do your maintenance. Ideally, you don't want your machinery to break down, right? So you don't want to do the second type, which is corrective maintenance. Ideally, you want to do preventive maintenance, and then you may never have to do corrective maintenance. That would be the goal. Other terms related to this would be planned or scheduled maintenance, right? Scheduled service may take place based on time or the availability of the person to do it. If you don't have the guy there that does the calibrations or the motor repair, then you can't do that when he's not there, right? So you have to have the people that are qualified for it. Corrective maintenance, equipment breaks down unexpectedly. You have to repair it or replace it before it can resume operation. This can be the most expensive type of maintenance due to production revenue lost, and because equipment failure can cause damage to other parts of machinery. One thing breaks, it makes another thing break, right? So that's the most expensive of the three. You can also do what's called predictive maintenance. Predictive maintenance is just using statistics to say, when would this device fail, right? And then replacing it before it actually fails. Now that can waste things sometimes. Hey, this motor probably has another year in it, right? It's kind of like doing tires on your car. If you put new tires on your car, could you have driven another 5,000 miles with your old tires? Well, maybe, right? But if you had a tire flat and you're on a 1,500-mile trip where you have to be somewhere at a specific time, that can be a very unexpected, expensive way to do maintenance on a car, right? So you would want to replace your tires ahead of time when they start going bad. And then I mentioned a little bit, so this is a very short little section here in the beginning, computerized maintenance management systems, CMMS, which once again, I didn't know a lot about until I started doing work for American Beverage Depot, and their maintenance manager showed me their CMMS software. And a lot of this does that scheduled maintenance and predictive maintenance. It gives you some tools to be able to do that, has all their part numbers in it, software, things like that. Now, if you can't afford something like this, and I imagine, you know, this is probably pretty expensive software. I've never bought any, but I would think it's expensive. You know, you could probably make your own equivalent CMMS system in Excel if you know what you're doing, right? You could do some simple formulas. You can log some times and tell when machinery is going to be going down, things like that. Once again, there is a little exercise in here for it in the book. What are the major three types of maintenance, right? I just listed them up there of the three categories, which is the most expensive. So part of the reason behind this book was that they wanted little quizzes and tests and things like that for the maintenance guys to kind of document the fact that they'd been through a course, which is, again, you know, that was part of the initial part of why I wrote this book. You know, it was at the urging of Automation NTH and Dexcom. Then I go through some basic mechanical things here. I'm not really going to cover a lot of this. This is very basic, you know, power transmission systems, things like that, gears and pulleys, motors, vibration. Some of the things we've already talked about. There's a lot of pictures in the book of, you know, couplings and things like that, talking about mechanical powertrains. So this is, again, in the very beginning part of the book, talk about some of the adjustments and maintenance that you can do on mechanical systems. I really broke this book down into a whole lot of different sections, right? And a lot of those sections, as you can see here, don't necessarily relate to each other. I have basic electricity in here. I have input devices and sensors, machine safety, you know, categories of safety, where all those come from, a little bit of machine vision. The Cognex section, as I mentioned here in this list, when I have something like an A document, that means I added the document after the book was published. And my intent there is that this book is a book that can be revised very easily by changing the individual sections. And then later down the road, I may have to decide, do I want to put Cognex or Keyence specific information in with the machine vision section? Is that a smart thing to do? I kind of tried to keep this generic like my first PLC book. I didn't make it specific to Allen Bradley or Siemens or whatever, because a lot of people use other kinds of PLCs. Some people may use ABB or Delta or different kinds of PLCs. So I don't want to make it all about Allen Bradley. Everything here should apply a little bit to everything. So these are some of the sections that are in there. I even had to break down the difference between P and ID and PID, right? So there's some stuff in here on PID circuits. I don't know if I broke that out separately. Let's see. Operational equipment effectiveness. Probably PID is somewhere back in here. So I had to differentiate anyway between P and ID and PID. PID will probably be something I break out a separate section on. I actually have a lot of good documentation on PID control for servo motors or for liquid level and things like that. So I may break that out of whatever section it's in. And again, it's not coming. Oh, there it is. Instrumentation and PID. So I have a PID section in there. That is not the same thing as P and ID, right? And of course, I had to spell it out here in the document name because you can't put the and sign in there, right? If you save it. So that's a little bit about what this is. So I kind of titled this Maintenance and Troubleshooting today. It's just the first couple sections of the book that I was covering. And again, I did mention that I am looking for somebody in the South Florida area. If you see this later, that can do some panel building and come into American Beverage Depot and get some things done. And again, I referred to this document. So here's a little bit of a look at that document. And the little diagram I had here kind of takes a while to refresh that, which was about this. So what I'm trying to do here is we can't probably do that job in-house, right? Because he doesn't have the people to do the job. There's a guy there, Umberto, who does pretty good panel building, right? He worked under my wife and kind of knows how she wires control panels. And then my wife doesn't really want to go down there and do it because it's 2 or 3 weeks of work, and she's getting older and closer to retirement. She really doesn't want to spend the time. Yet the owner of the plant really needs to get this done. So we're looking for somebody in the South Florida area that I can get together as a vendor. If you're a control panel shop, a small company, and you have a little bit of extra bandwidth, we'd love to get that done. Turnkey would represent, for instance, Automation NTH, giant UL panel shop. Could they do it? Yes, they could, but they're very, very busy right now. So it might be 2 or 3 months before you can get it done. And Juan Pablo down at American Beverage Depot needs it done now, right? Could I do it? I could. That's not necessarily a good use of my time, including drawing the electrical diagrams for the panels. Now, some people may ask, can that be done? Some people hit me up sometimes and they say, well, I do that, but I live in, India or Malaysia or something like that. You could, but there's a couple problems. One is we have probably a 12-hour time difference. So me interfacing with somebody that could do that, that would be one problem. 2, it might take as much of my time to check all the stuff out as it takes to just draw it myself. So that can be a problem. So what I'm really looking for is somebody in that geographical area in the southern half of Florida that I can kind of cut loose on it, the drawings and the panels and the parts and everything, and then be able to check the work from American Beverage Depot. The closer is for me to go out and take a look at it. The second alternative, if I can't find somebody down there to build the panel, Mario, if you're watching this, Mario's up in Indiana, Panel Boy Controls. If you have the extra bandwidth to do this soon, love to have you do it. But it's obviously harder for me from South Florida to Indiana. It's probably 1,500 miles. That's a 2-day drive to get up there and check the work. We could use cameras and things like that, and we'd have to ship it. We'd have to pay for that. And it's going to probably weigh, 1,500 pounds by the time you're done building a big 2-door cabinet like that. So that's the dilemma that we've got there. And so I'm going to actually get to test this and document it. And you know, do something down in this range. Lowest cost. He obviously wants to save money, but it's going to take a lot of resources. We're not going to have project managers. Probably I'm going to manage the project, but I'd like to be able to check the work, right? So it needs to probably be somebody not in California, for instance, that builds it, because I can't get out there to see it and test it and run it on site. It is just a big multi-conveyor control system. They have a couple spirals going up to the ceiling. It's going to have a bunch of VFDs in it, things like that. So if you see this in the next week or two, we are looking for control panel builders, again, in South Florida. You know, in Tennessee might be okay if there's somebody around here. So that was a little bit about what today was about. I mentioned the new book is out. It's been extracted. It's available on the website. A little look at the website at where it is. Let's see here. There's the website. There's the library. And there's all the documents. So if you're joining the Automation Academy, right, you can go to the library from the dashboard. And here's today, right? I put this on the site today. I said, this morning I'm doing my webinar. I haven't tried this yet on a Sunday, so I didn't know if anybody was going to show up or not, but it looks like Samarjit, I can see your name there that you showed up, but I don't see anybody else's names there. It shows a couple people that have attended, but anyway, that's the front of the book. Book sections are available. Just go here to the library and you can upload that. So that's a little bit of a look at the Automation Academy, right? We have videos, webinars. This is one of the webinars. The webinars everybody can access, right? So there's that series. We got a lot of PLC stuff on there. Allen Bradley, Siemens, other, and then of course we have the library. And my point about the library was, yes, you can now download all the sections of this book. It's a 384-page book that they're charging a lot of money for, and you can go download all the individual sections along with all this other fun stuff, right? Lots of PLC stuff, HMI stuff, devices. There's some software on here, technical miscellaneous, industry 4.0, documentation, wiring, CAD, lots of different things that I've put on here. And then there's even some tests, right? Some psychometric practice tests. This is for people that evaluate employees, right? They go and they say, do you have the aptitude for mechanical maintenance? Do you have the aptitude for electrical design, that kind of thing? So I put those on there because I got a hold of some of them. I don't remember how many there are, but numerical computation, verbal word meaning practice tests, all in English, of course. Mechanical reasoning practice, right? So if you are going to evaluate somebody for their aptitude, this is where you would start. You can actually download these tests. What they do, I'm going to give you a quick example of how you would open one of these documents. I had to protect a lot of this so that people can't just pass PDF addresses around. If I open the operational equipment effectiveness, what it does is it opens the PDF. You can see here, I put the document in information here, and then you can save it. So this is a section straight out of the book. I just copied sections out of the book here. There's OEE, how to calculate OEE, 6 big losses, you know, a lot of stuff that honestly, can you find all this stuff on the internet? Sure. I encapsulated it all in a book, but you can find the same stuff, and there's little tests in here. Right. So, and then I put my little blurb, and so people can download this as a PDF, and then they can share them all they want to. But if you do a save as or a download from here, all this stuff is once again on the website. So that's kind of all I was going to cover today on this. I've honestly run out of people to kind of interview, and you know, some of the past Mastering the Machines I've had guests on, and safety people and whatever. You know, it's hard for me to arrange those, and I'm not always able to quickly reach somebody. So you know, I've just started doing things like this, the random sections, and doing things that way. The next webinar is going to be April 30th. It's going to be more on this book. Who knows what topic I may hit next. I just did a bunch of stuff on machine vision. So I may do, more on that. I've got a bunch of cameras and things like that behind me. I may fire some of those up and make it operate. Let me go ahead and knock this out. Stop screen sharing. There's me. There's Samarjit. Looks like the only two of us on here. How you doing, Samarjit?
How are you, sir? Good morning.
I'm doing great. It's Sunday here, so it's kind of usually a day off, but I went ahead and made it on Sunday.
No issue actually, because sometimes Sunday I'm free because it's 8:30 p.m. Here in India right now. For at home.
Yep.
Yeah. Yes, sir. Yes, sir. Mostly
So,
I try to attend your class. Mostly whenever try.
Good. Yeah. So yeah, this book's worked out pretty well. It's a big, thick thing. Weighs about, 2 or 3 pounds or whatever, but it is finally out. It's kind of a match for my other book. So now I've got two about the same size with almost the same covers on them. And I'm trying to I'm trying to cover a little bit out of each book every 2 or 3 weeks. The next class will be in 3 weeks, and we'll see. I'm dedicated to doing this at least every few weeks, for the rest of the year anyway. We'll see.
Okay, sir. Definitely, I try to attend your class.
Great. It was good seeing you.
Yes. Thank you. Nice to talk.
Okay, good to talk to you too. And that's going to be it for today. Again, the next webinar will be on April 30th. I'm actually in Phoenix in 2 weeks, so I need to make sure that I have a weekend off. That is a Saturday. So more of this same topic. And thank you for showing up. You can find this on Automatici on YouTube, or just look up my company name, Automation Consulting LLC, and we will see you later